Hi, Danae. I hope you're doing well. I wanted to create a short video for you just to walk you through this particular example in the study guide with this STR data. So starting off here, just so you know, and you'll see an introduction in this, the beginning section of this particular question. Looking at STR data, so the STR stands for short tandem repeats. So these are just repeated sequences that you find within the human genome, and the number of repeats that an individual has is going to be unique for that individual. So typically, scientists will look at least 10 of these loci, these repeat loci, but in this particular example, you're only going to be looking at 3 loci. So this is that A, B, and C group that you see in this example. So this would be one loci here, here's your second loci, and then here's your third loci. So the first thing they tell you is that for the A group and C group, everyone is heterozygous. So when you hear the term heterozygous, that should tell you that an individual is going to have 2 different versions of something. So in this case, this is going to be that number of repeats. If someone is homozygous, so they say for the B group, individuals are homozygous except for Chris. Homo means same, and that is where you have the same number of repeats for a particular loci. So remember, you get 1 set of chromosomes from your mom, 1 set of chromosomes from your dad. So essentially you have 2 sets of all of your chromosomes, and that's why you can have 2 versions of a particular loci, or you may end up with the same version of a loci if your parents both contributed the same version. So that's what heterozygous and homozygous are referring to. Okay, so let's look at this first part. So Alex and Barb are a separated couple. So you see the information for Alex and Barb. Chris is Barb's new boyfriend. Doug and Ellen were children born to Alex and Barb when they were still together. So these should be legitimate children. And then Frank was born after Alex and Barb separated. And Barb is trying to say that Alex is the father and she wants him to pay child support. Alex does not believe that Frank is his child, and so he wants a paternity test. And so you should be able to analyze these STRs to see if Frank is possibly Alex's child or if he's possibly Chris's child. So the first thing you want to look at is this combination of STR loci that they have. So we'll look at Doug first, just because he is a legitimate child. And so these 2 had to have come from his parents. And so one had to have come from Barb and one had to have come from Alex. So in this case, this particular copy looks like it could have come from Barb or Alex, but this particular allele could have only come from Barb. So this is probably the one from Barb, and then this would be the one from Alex. If we look at this second loci, everybody's homozygous here, so he could have gotten one of these from each parent. And then when you look at the group C loci, this particular copy here could have come from Alex, and then this copy would have come from Barb. So it looks like Doug is a legitimate child. The same thing holds true for Ellen when you look at her copies. So it looks like this one is from Barb, and it looks like this second copy is from Alex. Same is true for the B group. Again, she's homozygous, so she probably got one of these from each parent. And then when you look at the group C loci, she got this one from Barb, and then this one on the far right would be from Alex. So it also looks like she is a legitimate child. When we look at Frank, Frank is a little bit different. So when you look at the A group, it looks like he could have gotten this one from Alex, and he could have gotten this one from Barb. So that's a possibility that he is Alex, is just looking at this A group. So when you look at Chris could have given this one, and Barb could have given this. So with the A group, it's hard to tell at this point. It's also going to be hard to tell with the B group, because technically he could have gotten one of these from Chris, and he could have gotten one of these from Barb. Same is true here. He could have gotten one of these from Alex and one of these from Barb. So with the B loci, we really can't tell. So then we look at the C loci. So in this case, when you look at the C loci, you can see that Alex has these two bands here. None of these are represented in Frank. So that should be, an indicator that there's something off here. So it looks like he has one of these copies that he could have gotten from Barb, and this second copy could not have come from Alex. It's most likely from Chris. Okay, so it looks more like Frank is not Alex's legitimate child, and he's possibly Chris's child. So can Alex be Frank's father? Why or why not? It looks like Alex is not Frank's father, just going by this C group loci, because he doesn't have either of these alleles or copies. Could Chris be Frank's father? Possibly. So he definitely has the right combination of alleles to give rise to what we're seeing with Frank. Does this test prove conclusively that either man is Frank's father? Why or why not? Really not at this point. You would definitely want to look at more loci. And they go through the answers at the bottom of this this worksheet. But you would definitely want to look at more of these loci, especially with Chris, to see if anything else would eliminate him, or if it completely includes him in this group. And then, does this test prove conclusively that either man is excluded from being Frank's father? Again, not necessarily. So mutations can happen from one generation to the next. And so it's possible that a mutation happened from Alex to when Frank was being born. And so there could have been a mutation that changed the pattern. So that's a little bit about how STR analysis works. I wanted to just create this short video for you to walk you through it, just in case we couldn't meet. If you have any more questions, please let me know.